Well, good afternoon, everybody. I know we are a small house, but sometimes we say better a small group of good people than a very large group of people that perhaps are not very much interested. Oh, but definitely gives me a very great pleasure to introduce both the speaker of this afternoon seminar and the subject. Now, I think the two go very well together. So it's the speaker is Dr. MVC Gowda, not our CLL Gowda, and unfortunately Dr. CLL Gowda is on travel, otherwise he would have been here welcoming Dr. MVC Gowda. What should I say about Dr. Gowda? It's perhaps will be a seminar in the seminar. So all I can say is that he has a very rich history of research and work in the agriculture research system in India. He has been a long-term collaborator with ICRISAT in other crops, I just learned, and is now the project coordinator of the All India Small Millet program. I hope I did not miss it, Major. And this is the All India Small Millet programs of ICAR, and is based in Bangalore. He has been a mentor, in addition of being a great researcher, he has been also a mentor of several researchers that are today working in agriculture research, several PhD students. So it's, I would say, a great scientist. Now, the subject of the seminar is small millet. Now, small millets in India is a current status and future trust. This is a subject that is very close to my heart and to the heart, I think, of Dr. Gowda and the other colleagues around this table. The day I joined ICRISAT, when I started going to my office, there were pictures of the ICRISAT mandated crops. There were 3 legumes and 2 cereals. And I immediately say, well, at least we should have also the 3rd cereal, and I think the 3rd cereal should be also finger millet. We have also other small millets, but let's start with the finger millet. So, and then we start discussing with colleagues in the program, and Santosh was very much active in that discussion. And so we start saying, okay, we should do a little bit more, because there are a lot of efforts going on finger millet, starting also from ICRISAT. At the beginning was mainly working on germplasm. Then now we have, for example, within the CRP on dryland cereals, we have also work on breeding on finger millet in East Africa. And when I was asking, being new, and say, but we work in East Africa, why we don't work in India? I mean, as ICRISAT on finger millet. Say, oh, you know, there is a very strong national program. So that's, we don't need to work on finger millet in India. But then my counter argument is that the fact that there is a strong national program is an additional good reason why actually we should do more on finger millet to start with, and perhaps other small millets when time comes. And this will be also a good way by which the Indian national program can even further help African national programs in their development of their finger millet breeding programs. And with this, I will leave the floor to Dr. Gowda to tell us about small millets in India. Thank you very much.
Thank you, Stefania, for your thoughts, and I know you are really passionate. I spent some time with her during lunchtime, and her perspectives are really wonderful as far as so-called, earlier they were called minor millets, minor crops or orphan crops, you said earlier. Then we started telling us small millets just to forget about that minor millets. Now people are trying to say that nutri cereals because of their nutritional advantage. So I recollect the initiative that was taken by CLL Gowda, and then Stefania, and then Santosh with Raji. They contacted several times and they had discussions also, we had correspondence, and then since this particular program on finger millet genomics initiative, they would like to have collaboration with us, and especially since our program on finger millet is well known in terms of output, so really they thought that that could be a good starting point for pushing this particular crop in Africa. So that's the reason why I'm here, and I was asked to give a presentation on our program and the status of small millets and Zambia. I would like to just say that I had a very long association, as mentioned by Stefania also, with ICAR. I know several of our friends are here also. Way back, it goes back to 1980s when I did my PhD at IRI for research work. I came here, and since then many of my students from Dharwad University of Agricultural Sciences, they did their research work here, and we had wonderful publications and also came through, and therefore I hope in this crop also, which is a nascent crop here, I think under the leadership of Stefania, something would develop and would benefit all the countries where these crops are from. I will just straight away proceed. Well, small millets in India, of course there could be some more also naturally, but here in India, in our own program, small millets consist of finger millet, which you all know is originated in Africa and then moved to India, and India is the #1 country in terms of its area production and also kind of impact that has made also, especially it is distributed all over India. Then the foxtail millet, the one which has originated from Central Asia. Is also an important crop. Then we have little millet, an indigenous species, domesticated in India. Barnyard millet, we have two types. One domesticated in Central Asia, and then and another type domesticated in India. Then Proso millet, again from Central Asia. Koda millet, an indigenous crop, very important crop in tribal areas. All these crops, they are very important in very harsh environments. So we deal with these crops. It is customary for us to talk about some very important features of these millets. They are very old crops, we all know. Like, for example, Proso and foxtail millet, they are some of the oldest crops domesticated. Likewise, all other crops are also very old, traditional crops of antiquity. They are associated with ethnic foods, food diversity, and then they are really suitable for dry lands, hill and tribal agriculture, especially very harsh environment. They also provide valuable fodder, especially finger millets, as talking about. It's very important in terms of fodder. Then other aspects are well known as far as these millets are concerned, especially in terms of their climate resilience, short duration. They make them wonderful crops for different cropping systems and continuously plantings. And then much more than anything else, in current scenario, people are really recognizing their nutritional properties. One can list any number, be it mineral nutrition, mineral composition, fiber, dietary fiber, quality protein, and nutraceuticals, and therefore now they are being recognized as nutri-cereals. We all know about this. So what is a sort of a distribution of these crops in India? When you see this picture, when all these crops are taken together, you see these dots everywhere. Even individual crops you will see in several states, right down from Tamil Nadu up in Uttarakhand in the Himalayas, from sea level to 13 to 14,000 feet in Uttarakhand, finger millet, and even foxtail millet in Arunachal Pradesh. Barnyard, for example, it is grown much beyond 13,000 feet in Uttarakhand as especially very important fodder crop. So they're, in terms of distribution, they're wonderful. But when we come down to what is the current scenario vis-a-vis earlier periods, for example, very interesting points are evident here. For example, other small millets put together, the statistics always is, and finger millet and other small millets are put together in projecting, and we see 5 million hectares. Of course, there is a gradual downtrend reaching 1.173 and even less than 1 million hectare currently. Likewise, in the productivity was really very, very stagnant. Very little impact has been made in terms of productivity. But when we look at finger millet, story is quite different. It was not as important as these crops, but see, it's maintained very well. 2.2 million hectares. It went up to 2.5, and then now it has come to 1.35 down. But when we look at the production, it has it has been maintained, except in the recent times there is slight decline. But productivity 2.5 times more. I always speak about, compare this millet with pearl millet and sorghum, which have hybrid technology. Their productivity in India is around 1 ton per hectare, whereas here 1.5 ton. That's the wonderful thing about this crop. And this picture also reveals the trend. But the next picture is one thing which I would like to just emphasize, different growth stories. This is the picture of finger millet performance in terms of area production and yield in Karnataka, which is a major state. About 60% of the area under finger millet in the country is in this particular state. If you see, it is all positive, be it productivity and production. There is a great jump, even from 1980s, there is a great jump. So it adjusts very well in terms of, say, for example, consumption, the market for it, and the productivity, the research output, all combined together to give a very positive story here. And this can be compared with any other positive stories of any of the major crops in terms of that particular area in Karnataka. And obviously we'll come back to the reasons for it. But look at this scenario of small millets. So very, very abysmal downtrend in terms of both area and production from, as I said earlier, and a very stagnant performance as far as productivity is concerned. Why these three different performance of finger millet in other states and finger millet in Karnataka and the other small millets in India is really a pointer which can be really investigated in terms of, as Stefania said, from different dimensions, maybe from food and competitive crops and research that has been put, and the policy, especially the policy in India is really was responsible for this particular performance. PDS, the emphasis on rice and wheat as a major crops has really affected the growth in these crops, especially the other small millets are substitute of to rice. Any product that could be made out of rice and the way it is cooked and way it is dehusked, etc., is similar to that of rice. So there were almost substitutes for rice, but grown in very harsh environments. But they were pushed. These crops were pushed by rice, obviously, because of its dominating feature and distribution. Production could be somewhere, and distribution and state-aided distribution, etc., was responsible. While that wonderful aspect of finger millet in Karnataka, so it has sustained in terms of staple food, and some pictures will reveal. Okay, before I go to that, this is the current scenario of finger millet and other small millets. Then we have statewide distribution. I said the Karnataka, nearly 60% of the area, and then other states like Uttarakhand, up in Himalayas, very important state Maharashtra, and then other states maybe 5 to 8%, then Andhra Pradesh is grown. As far as production is concerned, similar scenario, of course, more than 65%, 66% Karnataka's contribution. Then productivity, when we compare, there is great variation. This itself is very high as compared to other millets, as I said, but the C in Tamil Nadu, it is as high as 2.7 tons average yield. So the potential yield could be as much as 3 to 4 tons in rain-fed conditions. Likewise in Karnataka, in this particular year, it could be 2 tons per year in some of the years. But other states it could be quite less. This is the differences. I would like to just say one thing, why this finger millet is such a performance or story, is such a wonderful story. Last year, for example, was a very drought year in Karnataka, especially in the areas where this crop is grown. 35 to 40 days long stretch of drought was there, and we thought that we are going to lose all the crops, including finger millet, and there was a good rain, and believe it or not, about 50 to 60% potential was realized even last year, where other crops, even including deep-rooted crop like pigeon pea, failed. So especially in Alpi houses where rainfall is very uncertain, this has adapted very well, and that's one thing. And another very important aspect is, in recent years there is a lot of offtake by the industry. See the product range that is available in addition to main staple food in that area where it is grown. So these are certain things. Like, for example, one example I can give, but research is really required, that is not forthcoming. So a lot of ragi or finger millet is being taken by food industry. One example is Bombay is known for food industry. Every month there is a purchase from Bengaluru or in Karnataka. Earlier it was like something like 20 tons per month purchases. Now within 2-3 years it has gone up to 70 tons per. This is exclusively from Bombay market, Bombay food industry making purchases from Bangalore. So these are certain things which I can say, and realization, awareness now, and especially many products are available, though the impact may not be as good as we see in the case of oats like oats and other crops, but it's a good story because of these reasons. But other small millets, say, especially Madhya Pradesh and Chhattisgarh, a tribal belts of this is a very important crop, but when we come down to their performances, they are miserable. In terms of contribution, it is quite less, and when we see the productivity, say only Tamil Nadu, Uttaranchal or Uttarakhand and Andhra Pradesh and Gujarat are performing, but major states, their productivity is very, very low. So this is a point for us. Concerns, of course, area under small mills other than finger millet has declined drastically, so we need to look at to improve or sustain this, improving productivity and making them competitive. And then of course the consumption, the demand for these crops has declined, so we need to look from that angle. Now that's about the crop status, and now coming to our organization, All India Coordinated Small Millets Improvement Project, established an offshoot of earlier millet project, headquarters at US Bengaluru, GKVK. We have 14 AICSMIP centers, 16 voluntary centers, and with their different applied type of objectives. These are our centers spread over different states, concentrating on different groups of crops. And then we have cooperating centers. There are in different states like Tamil Nadu, Andhra Pradesh, and wherever these voluntary centers are more, the impact has been really very good. The mandates, of course, like any other AICSMIP mandates, we try to coordinate the research for the requirements, regional needs, then variety development, then crop production protection. We have transfer of technology, also taking up frontline demonstrations. Then to some extent, very less extent, we have research on value addition in grain processing also. So, and another very important aspect is genetic resources, because these were very historical crops, and a lot of good efforts, especially international efforts, earlier by Rockefeller Foundation was responsible, and later our own programs, Indian programs, were responsible for collecting a lot of germplasm. We have one of the largest germplasm collections in the world of these crops, and this is one very good aspect which we are also really looking at. Say, for example, these are the numbers, something like 15,000 germplasm collected from various sources, and we have good international collection that has made a big impact on improvement in finger millet also from Africa, because without Africa, our good story is also the international efforts made in the collection and transfer of this and utilization of this germplasm that has made big impact in finger millet improvement. That's one thing. And then we had evaluations and publications also. But one of the major aspects, say for example, on which very systematic effort has been made is on germplasm for resistant to blast. Blast is one of the very critical constraints in ragi or finger millet, and there is a good impact of blast resistant varieties in India, and we have made multi-locational tests, and several germplasm lines have been identified. Earlier, most of these came from African source, but systematic efforts in recent times have revealed that there are a lot of even Indian germplasm which are highly resistant, and African germplasm, since it comes from the islands, they are very sensitive to the high temperatures, and those are the problems which we face in some of our very excellent varieties. But we have new sources which could be used. Likewise, in other crops also, we have made some beginning in identifying very good sources of resistance for different diseases. And then we have made some very systematic work, and whenever we talk about these crops, they are often taken as drought resistant or drought escaping crops. Finger millet, for example, whether there is a need for breeding for further drought resistance, but our studies have revealed that there is enormous variation. For example, if you see, this is the potential of for like 4 tons per hectare, and the type of responses under drought from 45 to 75 days when drought was imposed, there was a lot of variation. This is one super variety we will come to know later, which has also shown very high level of sensitivity reduction as a result of drought, but there are other cultures, germplasm, which are really good, which could be used in future breeding programs. So visually, pictorially, we can appreciate this difference. Sensitive varieties and the tolerant varieties, see the differences here and see the differences over there, and also commercially successful variety. There is a potential, this could be transferred to these commercially potential varieties. So there is a lot of scope in terms of drought resistance breeding. Likewise, as I was talking about high temperature, this crop being originated in Africa and islands. So many genotypes or accessions that are highly sensitive, especially those which come from Africa, they're highly sensitive. So when we use them for, say, enhancing productivity or blast resistance, we often also transfer. We never knew about this, but now the little analysis has shown that in fact this is one feature, but we need to look for there is great variation again in this particular parameter. That's also evident in this picture, the differences. Likewise, of course, whenever we talk about these crops, we also talk about nutritional quality. Unfortunately, not much work is being done, and I look forward to ICAR because very good facilities are there as far as nutritional profiling is concerned. I think in future, in all these crops, there should be some systematic collaboration in terms of profiling at least maybe core and varieties which are available. Nearly 200 varieties are there in different crops, and in single millet nearly 100 varieties are there. So that should be looked at. But our preliminary analysis, multi-location analysis, again revealed that many of our popular varieties, they are very, very low in protein content as compared to some of the, say, germplasm accessions. There is a potential for scope for improving these, and definitely these aspects have not been taken care of in breeding programs either too. Finger millet again is really very good crop, as I said, for confectionery purpose. There are many food products that have been used or generated and which are very, very popular, especially in Karnataka, made out of popped grains, and there is a tremendous variation in popping. So there is again potential scope for developing varieties which are very, very specific to industrial needs also. There are other parameters one can also look into. That is the picture, differences in varieties in popping. So we are trying now at present to look for abiotic and biotic stress and nutritional profiling of germplasm, identify ones, and then use in breeding programs. What is the sort of crop improvement that has gone in these crops? Of course, whenever we talk about crop improvement, finger millet comes to mind because not much has been done in other crops. It is only selection. And say this is a scenario. So from the time of establishment of our unit till 2011, as many as 120 varieties. Many more are there which were released previous to this point, were released. And if you look at different methods by which these varieties were developed, you see in all these millets, it's only essentially selection, especially in Kodo, which is not amenable for hybridization. There is a need for basic research on that aspect also. But in finger millet, it's quite contrasting. Hybridization has contributed quite a bit, large number, and therefore the positive aspect picture about finger millet could be because of this. In fact, it is because one of the reasons is because of this. But in other crops, there is a need again to really push this hybridization. Many of these crops, there is a difficulty in hybridization because of small floret size. So that's one very big hindrance even in finger millet, and there are some efforts to overcome that. I will talk about it. So I would like to take just a finger millet as a case study. There is a big improvement, and this is something like 47 kgs per hectare per year. And if you have any idea about type of improvement that has gone in other crops, including maize, wheat, rice, etc., this easily comparable to that 45 kgs. Even in corn, so-called wonderful crop, this impact, so impact of research is there very well in terms of this. So in Karnataka, for example, where a good amount of breeding work has gone in, there were different phases. Earlier it was restricted to exploiting indigenous variability, wherein the varieties which were simultaneously evolved, they had this sort of a potential in the field. Then use of exotic germplasm, especially from Africa, Indo-African crosses, which saw great germ, and it got stabilized and pushed further and blast resistance again from African germplasm was incorporated. It's a really wonderful story, we can say. So that is also evident when we pull these into land races, in Indian land races, selection from land races, and then in the African derivatives. They were earlier popularly known as Index series. in Karnataka and HR series. Then we have GPUs and MR series now. There is a gradual increase. So it's really impact of the type of crop improvement therapy. I was talking about one super variety, GPU 28, which nearly covers 70% of the area in Karnataka. It has made a very big impact, especially because of its medium duration. Then very high level of resistance, which has been maintained since about 18 to 20 years, very stable, covers 70% of the area. And it has really pushed yield at the farm level, farmers level from 10 to 20 quintals on an average. Potential in the farmer's field is anywhere between 35 to 45 also. So that's a super variety. How this impact was possible in Karnataka? Again, the success story of the seed which was missing in other millets. See the amount of seed that is being supplied through State Seed Corporation, 16,000 quintals. See, 16 to 18,000. This is a big difference between Karnataka and other states in terms of finger millet, but in all small millets, this seed production chain is missing, unfortunately. But among that, GPU 28, the super variety, as we say, has really contributed even to tune of 85 to 90% many years. So that's a wonderful thing. Likewise, of course, we have potential varieties being developed through hybridization, especially in foxtail millet. Andhra Pradesh, very good work has been done, and this foxtail also matures very early, 75 to 80 days, and it fits in so very well. And there is great realization and increased demand from cities now, because we all know that India is the diabetic capital of the world, and there is a conscious demand from the population, diabetic population from urban areas, and therefore nowadays there is a jump in the cultivation of this crop, 20 to 25 quintals per hectare. That's a wonderful thing. Likewise, I was talking about barnyard millet in Uttarakhand, and this is one particular success story associated with ICAR also. It is a selection from the ICAR germplasm, introduced from Japan. So this is a success story. This is a multiple disease resistance, as well as high fodder and grain potential is there. This is a very popular also. So I was talking about small millets and difficulty in hybridization. One of the answers could be male sterile line, and in ICAR one particular genetic male sterile line was identified. But we all know that genetic male sterile is very difficult to maintain. We need to get back to heterozygotes and segregate, etc. But in the background of GPU 28, which is a super variety, we got a partial sterility governed again by nuclear gene, single gene. In this particular case, the success is fantastic in the sense it could be easily maintained by sulfing, and then whenever we use for hybridization, there is a high level of even F1 recovery as high as 70%, which is being used in recombination breeding, and we are also in the process of developing hybrid technology. Certain work has been done already. So this gives really some interesting features about this male sterile line. So this is a fertile version, something like seed set is 70%, and when it's self, this partial male sterile about around 10%. When we just keep it open, it goes up to 20%. It can go further up, provided we give sufficient conditions for crossing. It can go further. So whenever we raise this through breeding, so it could be easily maintained. That's a fantastic thing about it. There is a scope for outcrossing. This we have exploited in recombination breeding, as well as we are trying to see whether we can go for even hybrid technology using this. Say for example, when we use GPU 28, the fertile version, and make crosses only 4%, 76, 64, 45. So that is the enormity success we can get. This is one picture which shows number of hybrids, the purple ones. And we are trying to link or associate or incorporate a marker which could be used as seedling marker, virescent marker. In hybrid technology, these markers are being used in rice, for example, in two-line hybrid systems. In the very early stage, it is virescent, but later it turns green. So this could be very well, we are thinking of using this particular in hybrid technology. So these are some of the initiatives I've already talked about. So the crux of the point I told that is seed production, which is missing in many crops, other crops, and many states even in finger millet. So this gives so absence of institutional arrangement, especially. Say we do produce a lot of breeder seed, but it does not get translated into foundation and certified seed, and seed distribution is a big problem. This just to show. So some of the approaches we are really thinking, and there is a definite program now, initiative of nutritional security through intensive millet production. A lot of effort is going on. There is support for seed production and distribution. Then alternate seed systems like involvement of NGOs and seed supply systems, seed cooperatives, etc. are being thought of. So crop production. In the crop production, the main thing is competition. These crops are losing, even including finger millet in other states, losing competition to other crops. This is where the crux of the problem is, and we are tuning up our crop production technologies, especially on those lines. And then more important in recent times, especially finger millet is a very labor-intensive crop, and labor has become a really very big problem, especially with the advent of MNREGA and other programs. So agriculture is losing labor, and wherever labor-intensive operations are there, they are losing in agriculture also. So this is our focal point, selective mechanization. One of the very impressive research output has come in terms of intercropping systems, though these systems were very old traditional, but there is a great revival. So combination of crops really, they are more profitable, and they are becoming very, very popular among farmers and more sustainable also. Likewise in multiple cropping in, for example, in foxtail millet in Andhra Pradesh, earlier only chickpea was being grown, and now there is not much reduction when two crops are taken up, and farmers are in big way, they are going for foxtail millet, especially in Kurnool district. So this is becoming very popular with the advent of early maturing varieties. So mechanization, for example, I thought that it is really very important, especially our harvesting operation. Varietal differences are there. Some of our recent varieties, they are lodging tolerant, they are more amenable for, say, for example, this particular variety for mechanical harvesting. So our future varieties are all will be of this kind, like in major crops. There is also possibility of developing these crops. Then as far as crop production is concerned, main emphasis, not many diseases are there, but wherever these diseases are there, our main emphasis is on economical methods like seed treatment or IPM technology, and mostly on disease resistance, especially coming to finger millet, since when we look at rice story, there is a lot of dynamics in terms of races, etc. It may not be same in the case of finger millet, but not much understanding has gone in terms of finger millet, and we are really emphasizing and looking at races prevailing in the country. And then one another aspect is shoot fly menace and other millets is really very important, and we are concentrating on developing IPM technology for that. This is about. Then of course crux of the problem again is the demand and realization, awareness, and especially the young generation. If you look at traditional foods, etc., of course we all know that our young generation would not like it, so there is a need for transformation in terms of developing ready to eat or ready to cook food products which are more appealing in terms of knowledge. Also there is a need for spread of their benefits also, that is there. So these are the key issues. Some of the technologies that have been developed, we have a center at CFTRI, Central Food Technological Research Institute. They have done quite a bit of work, and some technologies have been developed. One of the critical technology in other small millets is lack of suitable de-huskers, the milling. process is critical, and this milled rice cannot be stored for a long time. So it has to be milled and then used in a short periods, and therefore for small communities or house consumption or small companies, there is a need for, and there is a effort that is going on which has been successful in developing these machines in our project or network mode. So our initiatives, some of the initiatives in this particular line is development of technologies for enhancing shelf life. As I said, this is one critical problem. Then machinery to enhance the consumption. Then many small scale entrepreneurs are really interested, and there are a lot of work that has gone in home science departments of agricultural universities. Many products are available, but unfortunately the translation is not taking place, and our emphasis in this plan period is imparting training to these and small farmers. Another very important aspect, because these transfer of technology has not been very effective in many states, except as I said, Ragi in the case of finger millet, except in the case of Karnataka, in other cases. So one of the effort in our project is conduct of these frontline demonstrations, number of farmers, and you can see within 2 years of so many acreages or hectares of demonstrations that is being done, and the type of impacts that were evident, in the sense differences, the potential of the new technology in terms of new varieties as well as slightly modified technologies, recommended technologies, very great potential is there to push in, provided these are adapted. Especially government now supports through some of the programs like ICAR program, where even inputs are being given, and these crops, especially sorghum and pearl millet and ragi, the finger millet, are being included in TDS program, and also minimum support price is being raised. So I think there is a policy shift in recent years towards some of these major millets. So we hope that the other small millets, especially that come now they are recognized as very specialized crops for nutraceutical or health point of view are concerned, but they should come wherein there should be widespread usage of those crops also because of their health benefits. So one very important constraint what we face in our All India Coordinated Research Project is we don't have an institutional setup. For example, I was just discussing just a short while ago, when we talk about sorghum, there is a great institute of ICAR, and even in the Indian program, we have a Directorate of Sorghum Research. Likewise, for pearl millet, India has benefited tremendously from the work of ICAR as far as basic and strategic research is concerned. Unfortunately, these crops, say, institutional setup is missing, and very little basic and strategic research has been done, and any development that has taken place is because of involvement of some of the breeders or some scientists through individual effort, a lot of dedication, etc., that has gone in developing. But the system is missing, and that's where we are really looking for. Of course, there is a move that in India, a millet institute may be started in Hyderabad. The Sorghum Research Institute may be changed over to as a Millet Institute, National Millet Institute, but even there probably emphasis may not be again forthcoming because major crops will take over. So some of the initiatives what we have taken in by collaborating with different state agriculture universities, some departments where excellent work is going on, we are trying to collaborate different institutions, ICAR institutions. These are some of the areas where we are trying to concentrate, hybrid technology. Then we are trying to look at these genomic tools, but we have not come to the point at which they can be applied, but there are some initiatives in terms of developing mapping populations and good phenotyping. So we look forward very well to ICAR, especially in these areas of research, so that joining together we can really contribute much more. Again, as I said, we always talk about nutritional quality, both grain and fodder, but very little information is available. This is another area which really needs a lot of emphasis. And again, ICAR is really good at it, profiling, nutritional profiling. I look forward whether some collaborative programs could be initiated for the benefit of both the organizations and the communities, millet growers. Then, of course, crop improvement, our main emphasis in finger millet is in blast disease and shoot fly in other millets. Then, of course, we are also looking at drought, temperature, and salinity. These are wonderful crops again for salinity. But systematic work has not gone in. Like, for example, barnyard millet, and even for finger millet and foxtail millet, they show wonderful salinity tolerance, some of the accessions especially. So more systematic work needs to be done so that these crops could be grown in some of such areas where other crops cannot be grown profitably, could be exploited. So, of course, since our programs exist in the different universities, we have benefit of some of the students working on that. Of course, many a times students do not prefer these crops, but if some very strong programs are there, like our male sterility or some other program, blast resistance, etc., students are excited and they do prefer some of them. And we have some of these students working on nutritional profiling in finger millet and foxtail millet for calcium, zinc, Fe, and protein. Then survey of blast racial patterns, one of our students is working on that. Then use of this partial male sterility in hybrid development of hybrid technology and recombination breeding through recurrent selection programs. People are looking at, our students are trying to. Some of our students have also developed very systematically mapping populations, very advanced stage for blast, and we are also in the process of developing, because we have really very distinct germplasm lines for drought and especially temperature tolerance, and we are in the process of developing. And some small initiatives have gone in for looking at polymorphism through rat sequencing, but it is not much, but we are really interested in this area. And very systematic phenotypic data is being collected from multi-locations. That is a wonderful thing, because in the present juncture, we all know that we can outsource genomics work, but not phenotyping work, and that's a critical constraint in many programs, even in major crops. But I am confident that we are going to generate, especially in blast, very good information, because we have hotspots for this particular disease, and we have breeders and pathologists working in different centers who are really collaborating in generating the information. So as I said earlier on also, some of our thrust areas, the last slide. So we are also at CFTRI trying to look at phytochemicals and with nutraceutical properties, etc., in a small way. But this is one very important way. We always talk about millets in terms of health foods, functional foods, and epidemiologically speaking, they are wonderful. There is less cancer or other problems, also diabetic, etc., but all the evidences are not forthcoming. So we are trying to strengthen this particular aspect of research. Even we are open for even other institutions, but not many people are interested in concentrating on these crops. That is another major setback. We all know about it. This is one area we are looking at. And the other area, this is a really, many people are trying to, they are interested in really growing these crops and preparing some products and selling also, but milling is a critical problem that is being tackled really under present scenario. Then, as I said, biofortification, people are talking about, and the success story is there as far as pearl millet is concerned through, but though these crops are termed as nutri-cereals, but not much information is available as far as profiling of varieties are concerned. This basic information definitely will lead to something on biofortified crops also, or varieties in future. This is an immediate concern. This is a really very immediate concern. So our thrust is also to develop crop improvement in a bigger way, much rapidly, using modern tools also. So that's also there. But of course, AICSMIP as such may not be really equipped, and therefore there is a greater need to come together in a collaborative mode to take up such issues. So, so thank you. So these are the few things, and thank you very much. And if there are questions, I will be happy to discuss on any issue.
Yeah, thank you very much, Dr. Gowda, for reminding us about these minor millets or small millets and nutritional millets. In fact, during my childhood days, the pearl millet used to be, or finger millet used to be half the diet of the whole village. Now, the new generation maybe have not seen those millets at all. And those days we used to transplant them. Is there any advantage of transplanting or direct seeding? Farmers used to say transplanted ragi or transplanted millet would give better yield, at least 10-15% better yield than direct seeding.
Okay. When it comes to, say, for example, current scenario is the cost that is involved, and many a times if conditions are proper, even direct seeding can match transplanting. So there is no need always go for. But whenever a crop is grown in Karnataka, for example, in off season, in summer season, and in post rainy season, where irrigation is preferred or should be given, at that time it is exclusively transplanted condition. And this crop, for example, if you throw the seedlings, it can really establish very well. So that transplanting ability is also there. It can sustain dry conditions, and also it can sustain to some extent waterlogged conditions. And establishment and recovery from the drought is wonderful in this particular crop. So there are many things which have not been understood. For example, people say that there are something to do with root system, etc. That basic information is really missing. For example, one another issue is calcium content of grains. It is 10 times more than rice, for example, and very rich as compared to any other cereal grain. But how it accumulates so much calcium? Can we really look at the allele mining perspective is concerned? Can we use that capacity in other cereals like rice or any other cereal is wonderful thing. Likewise, one can list any number of features these crops exhibit which can be of tremendous help in terms of basic work, genomics work, to other crops also, improvement of other crops. Yeah. And as far as your comment on food is concerned, definitely there is a decline in terms of our new generation, and therefore there is a need for developing some food items which are more attractive, and also the type of advertisement we need to take, and that is really very, very important, the ready to eat and ready to cook. So we always often quote the example of oats, for example. Now it has become even a common thing in our villages, wherever shops are there, and small towns, a lot of people do consume, telling about its positive benefits, etc., etc. And each one of these grains is no way inferior to oats. But what is missing is the type of technology that has gone in for oats, transforming into a valuable item, is missing here. So there is a need really to put in good research in transforming these grains into value-added products.
Yeah. Like you said, our canteen is really supplying ragi bread and ragi dosa.
That is very common.
That way. But another thing you mentioned a couple of times, the shoot fly. These millets, they produce a lot of tillers. And is it really a big problem?
Whenever the crop is grown little late, The population buildup is so much. We were unable to raise good crop in Bengaluru. For example, foxtail was not the case. Earlier, shoot fly incidence was not at all there, but now it has become a very serious problem. And it is a big problem in proso millet and little millet, especially when we delay the sowing. It all depends on the rains. So there is possibility of building up, and there is possibility of losing it. Therefore, good technology should be there, yeah, for that.
The fruit fly is same as the sorghum one? Is the same
Yeah,
species?
no, different species. Each species of small millets is attacked by different species. It is something different from sorghum shoot fly. But I think good work has been done by Dr. Sharma and others, and something we really look forward to something, say, starting up of some good initiative on our crops with the input from, say, AICSMIP. It could be nice, especially that has become a big menace. Not sure.
Thank you, Stefania. Thank you very much, sir. Good afternoon. Very nice presentation. So you always work on those species which are having two genomes, huh? The groundnut of the finger.
Yeah, that's
not
right.
satisfied with one genome.
Foxtail is deployed.
Fox, yeah.
Yeah, but yeah.
So, although you mentioned about the germ plant that about 15,000 accessions,
Yeah.
different places,
Yeah.
and on the other day we were having this telephonic discussion, but it will be good if you can just highlight once again that you mentioned that there are two genomes, and for one genome you have an idea, what not for the other one. So
Yeah.
can you please highlight?
Yeah. Finger millet is a hollow polyploid like groundnut. One of her progenitors is a very notorious weed throughout the world, especially tropical, subtropical, that is the Elysian indica. Okay, and there is wonderful work also is being done on weed aspect. There is a lot of herbicide resistance that is already prevailing. So one can also project that particular angle as far as indica is concerned. So, yeah. But the other one is the B genome, but it is not confirmed. But one of the possible donor is Fluxifolia, FLOCCI, Fluxifolia. Yeah, that germ, the seeds of which is not available here. So possibly there should be some effort from your side to get it. USDA they have that. Yeah. There is another species B, which is also not available here. Many A species are available even in ICAR gene bank. We have 5 or 6 of them. Apart from indica, indica is everywhere. In the roadside, you find a lot of it. There are 2 B genome species and 5 or 6 A genome species available. No. B genome species are not available. A genome and E and B. B, yeah, E. A and B, yeah, that's right. Yeah, I think they have both. Yeah, you should be able to access it, to get it, Chinese, they are working mostly on foxtail millet. Wonderful work is going on there. Yeah, not much into the millet. Yeah. Foxtail, for example, they have hybrid technology. Yeah. This NCBS, National Center for Yeah, they are helping. Yeah. We have just initiated, but not in a big way. It is a scratch, very scratchy. Yeah, that's right. Yeah. But not in a big way. Bioinformatics and other things, they are not really. Shailaja had a MacNight project, earlier, about 10 years back. So they try to get genomic resources from University of Georgia, Catherine Davis, and that has been used in fingerprinting from germplasm, as well as one of the mapping population was developed, but unfortunately that is not there, population is not there. But this Georgia, they have developed one partial linkage map, but that's very skeletal. Yes, it's a markers. Yeah. Not much. It's only academic interest, you can say. nothing beyond that. Yeah. A and B, they have not been differentiated. Yeah. 36. Yeah. I don't know. I just remember. Do you remember? 20. Yeah. Yeah. That's a more. So obviously, they are not. Yeah. No, okay. That's good. So how much, what is the extent of coverage?
So for Ramu as well as to Dr. Gowda, so even NCBS is doing the GPS and the government people are doing GPS. So GPS is okay, but until unless you have a different genome.
Yeah, that's right. Yeah.
And then in the end, you will identify they will not be very difficult. Yes?
Yeah.
Second is that you don't know that whether they are really SNPs.
Yeah.
And especially when you are dealing with the tetraploid species Ramu, then things are more challenging.
Yeah.
And when you do the SNP calling, because when you are having these allo tetraploid kind of thing.
Yes.
If you are having two different genomes, it's easy. But when you are having these allo kind of thing, then this
If just a genome can be profiled, I think that can decipher.
I think that should be the best.
So that's what we have been discussing, sir, is at least if you are able to get some information, even if it's rudimentary or genome survey of, let's say, a genome, we can at least try to look into the synchrony between A and B, how far they are related. That will at least help him to try to organize our genetic nodes.
No, so if you will have the GSS, you will have the information only from the A genome. Until unless you have the information
Of
from
course,
B
both on
genome.
them.
You
Of course, both
cannot
on
have
them.
the synthesis.
Yeah, both of them, of course.
Yeah, but then from where you will bring the B genome, that's the problem. So this G28 is very interesting genotype.
GPU.
GP28.
Yeah, wonderful. It is an Indo-African derivative, Indian germplasm and African germplasm.
So this is the variety developed by
Yeah, our own unit. At
since you moved to Bangalore.
Yeah, no, much earlier. It's 20 years.
And GP28 is highly homozygous,
Yeah, definitely.
100%.
Yeah. In one
You
need
don't have the
to start
issue of the
with
heterogeneity or heterozygosity,
heterogeneity could be there, but one need to start with a single
but
point.
homozygosity will be 100%.
Yeah.
Heterogeneity can be taken care of if we just continue with one seed source.
Yeah.
Any more questions? Then, if there are no more questions to Dr. Gowda, well, first of all, I would like to thank Dr. Gowda for taking this time to come here to ICAR, to give this seminar to us, to share his extreme, I find so much information, so rich in terms of knowledge, a seminar that to me has been really a great pleasure and a big learning experience. And this is what I always say when I listen to a presentation like this. This is what I consider a crop improvement program that can tell you a story. It's not like having an experiment, telling, okay, these are the results, but just giving the full story of the program. And that is something that is becoming more and more rare to actually see this really, real, what I consider a successful story. Now, as we were mentioning from the beginning, we are talking about, we call it small millets. People were used to say orphan crops. We don't want to say anymore, they are no more orphan, because if they are orphan, it means that they have not found a house yet, they have not found parents. But we are very much interested in, at least in the case of finger millet, and we would like very much to get our research and our resources together so that we can create that critical mass that is needed to bring those crops to another level. Before I close, I would just like to say, well, why don't we look at the example of quinoa? Now, quinoa is is a fall cereal. It is grown up in the Andean region, comes from there. If you look at the coverage in terms of area, it's a little tiny portion of the millets in general. Now, 2013 was declared the year of quinoa. They were able to make so much awareness, so much noise about this quinoa, so much nutritious crop. It's nothing better than our millets. Why cannot we do the same with our millets? If you go to supermarket in Hyderabad, you find quinoa on the shelves. It is there, yes. It is also, and it actually says, some is imported, some it says organically grown in India. Now, why we cannot have the same story for our millets, rather than waiting for people from the Andean region coming here and bringing their own crops? I think we have a wealth of diversity, crops, so let's look at what was really successful in the quinoa story, and let's see whether we could repeat it with our millets. And with this, I would like to request you all to thank again Dr. Gowda and to show him our deep appreciation. Thank you.